All right, here we go. So I pushed back the due date a couple days. It's due Monday night. That'll give you the whole weekend. And towards the end of the period, I'm happy to take individual stuff. And prior to that, I'll take questions. There are a couple things I wanted to talk about. I guess I'll start with if there are any general questions you want to ask.
I just got out of a midterm. My brain, it takes a little bit for me to get there.
That's fine. All right, then I will plow forward. We've been working with expressions now a fair amount here with the parsing and the underlying code for it. So I wanted to explore that a little bit. And hang on. There we go. Nobody's using the CTOD type thing. All right. Oh, there's someone. Welcome aboard. Make life easier if you're unable to read that from far back. Oh, one thing I wanted to talk a little bit about. So we have a fairly elaborate hierarchy, inheritance hierarchy, and it certainly does make for some extra typing. You have to bust out each of those evaluate functions and the class declaration for every operator and so forth. Why is it that I'm pushing that model down your throat? In general, going to such elaborate lengths to create a nice hierarchy.
Modular and useful.
Yeah, I suppose you could say it's modular and useful. You could also say it's modular and a hassle. Constant.
That's what professional software engineers use.
Yeah, that's not an answer. Professionals aren't always right. One of the things that I mentioned in the past about the benefit of it is that we're trying as much as, actually it goes back to, we did do this as an exercise, that shapes versus shapes shifter, remember that assignment? What was kind of the bottom line of that? What was the advantage to using the polymorphism in the classes as opposed to not just having a single class? Yeah, go ahead.
The volume of code increases much less without polymorphism than if you were explicitly defining
everything. I'm not sure the code increases less. I'd even go as far as to say it's possible the amount of typing that you do to enter all the classes and so forth could mean a little bit more code. But what about complexity? Yeah.
It is more scalable.
Well, what does that mean? More scalable? I could scale both of them.
Well, if you have lots and lots of derived classes that you need to store, if you create an object, it doesn't have all the possible derived types. You don't need to edit the original definition. You just add new ones.
All right, okay, so that's an interesting idea. You don't have to edit the original definition. You just add new ones on top of it, and you aren't editing existing code. That's certainly true. Maybe I should find that and download it. It's this one. So one of the things I did was I am not going to do it this way. Sorry. My car's ready. Oh, it's already in there. All right. So let me do this. Let me do this. All right. So if I grep for if and shapeshifter, if I grep for if in shapes. So shapes was the one that uses classes, whereas there are fewer classes, basically one class, and then we did some decision making as to what type it was. And one of the key takeaways I wanted from that was that we are pushing decisions to compile time rather than run time is one of the things we're doing. Or to the extent we're not pushing it to compile time, we're certainly pushing it onto the compiler to make the decision as opposed to us, right? So there's less decision making branching that we have to do when we get a properly architected hierarchy. So I wanted to use that as preamble just to share an anecdote of what an implementation, a typical portion of code of the implementation of these projects looks like if you use a flatter design with far fewer classes, where you end up doing this former case here. And so I grabbed an excerpt of code here. All right, so you see you end up having code that looks like this. So that's one of the what I would promote as one of the main benefits to the hierarchy as it's designed, is it removes a lot of this decision making, takes it out of our hands, and lets the compiler handle that. Let me talk about a different subject regarding expressions. I went ahead and typed this in just for class. Help me out with a 111 level cout statement to print out the, I don't know, the third letter. Array what? No. Just print out the letter A.
Hard bracket 3.
All right. So, oop. Am I not in? What? Oh, I didn't build it, did I? All right, no mystery there. What is this? So I would say, yeah, it's a pointer, or it's a little bit. I'm not going to quite get what I'm hoping for, though. If let me compile over here. And unfortunately, arrays of characters have a special, they inherited from the C language. Arrays of characters have a special connotation, which is we use them to hold pros, right? Language. And so we get it running an algorithm if it's presented with an address. So let me just for the sake of moving the discussion on, if I come here and let me replace this with and so sure enough, we do get an address, all right? So what's happening on line 19 then? Would everyone agree with the assertion that an address is really nothing more than a simple number? Let's see. Well, rather than using the old C style cast, we'll go C++ here. Let me put it on multiple lines. Now I should be able to print that out. This should be the address of array. I'm sorry, excuse me, adder. So what's the address of the letter A then in that array? It's this number plus 3, yeah? Everyone buy that? Okay, so I want to keep this all on the screen, so I'm just going to cram that all onto one line. Do that, give me a little more space. Let me see, I'll get rid of the float stuff, I don't need that. Alright, so the demonstration of it, we basically reinterpret it as an integer, or a long integer, a courtesy output, and then how about unsigned long larger, I don't know, equals ADDR plus 3. Now I can reinterpret that again. So let me copy this, paste it here. Let me reinterpret it now as what it was originally, which was a character pointer. Oh, let me see. Let me go ahead and go back to that type. Let's call this the character offset equals this. And now I should be able to dereference that character offset and get my fourth letter, which is P. Well, I was using A, wasn't I? 2. Let me make that 2. That makes sense? We just convert it to a number, then we do some simple addition on it. We tell it that no, it's no longer a simple number, it's actually our character pointer again, and then we print out that pointer, but we add this asterisk to dereference it to get the contents of that address. Constantine?
Maybe we should use data type in pointer underscore t.
No, this works. It worked. So, in GPL, this right here, these brackets comprise an operator, right? And if you go to here and you type C++ precedence, we do indeed find that right here, at a very high precedence, that is an actual operator in the exact same sense that addition or subtraction, the plus or minus here, is an operator. In fact, I'd go so far to say that it is a binary operator because there are two arguments that that operator operates on. Here, the letter A, and then whatever goes inside there. So what we could do is just to play make-believe a little bit. This is from our project 3, the evaluate function. We could imagine an evaluate function, evaluate left-hand side, right-hand side. So if this was the subscript operator, maybe. Then let's just simplify this and not worry about all the type checking and so forth. So we have an expression kind of like this. In fact, let's just get it down to the bare bones here. This will ultimately be returned. Let's just focus on this expression. So basically what it needs to do is it needs to add these two together, which is what we did right here. And then it needs to dereference it, yes? So let me put parentheses around that. I'm going to add those two together, and then I'm going to dereference it. Now the details might be a little different. You might call this as address or something like that. You could certainly debate that, but am I making a convincing argument that perhaps something very similar to this is actually being done in C++? All right. How can we prove that? So what it's doing, let's then just write that formally. That would be doing an asterisk. It would be ADDR plus 3. I'm sorry, damn it. No, I got it. It's like, it hurts my ego if I admit defeat. All right, so we should see that. Let me quit out of this for a moment. Oops. Let me go back to what's our original array. All right, so far so good. Now here's the golden question. This is adding together two numbers here. That means that it can do something like that. Here's my question for you. It's not a hard question. What's that equal to? Okay. Then what is this equal to? What it should be you're not. It's causing you to pause and think about it, but it shouldn't. It's simple addition arithmetic, yes? The associativity. Oops. All right. What about this?
What if we do cout to index by the string literal grade? Let's do that. Why not?
What was my word? Great.
Pointers.
Yeah.
How the heck does line 22 work?
It works the exact same way line 21 works.
And 23 works the same
It
way.
just doesn't seem to make sense, though.
It makes perfect sense because when you use the subscript, it's just doing something kind of like this. Right? It's adding two things together and then dereferencing it. That's it.
What about the grade one? Does that make a CSAL string temporarily? Or how does that work?
So what on line 23, let's go back to something more akin to 111, which is char star str equals, right? You all accept that? It's just an address. What it is it's a literal array of characters, and you're given the address to it.
So 23 is just like a quick make a string, delete the string right after, or would that be memory leak?
No, it's not a memory leak. It's cleaned up just fine. It's just like saying int a, right? Or a better example would be 23, or even that digit 2 there. You're not leaking memory by using the literal digit 2 there.
But if you would just let's say the 2 memory is allocated here, memory is allocated in the global section. A string literal in the global section, it returns a pointer, a character pointer to that global section where the actual text is stored. And also, if you have multiple string literals with the same exact, like great same exact letters, they all are linked into one in the global section, and all the pointers returned by those string literals are identical.
Okay. So that's that. Just a fun trick to get a free drink at the bar.
Also, maybe I would do.
Well, why do you get free drinks?
That's right. Well, I actually end up, after trying these tricks a bit, I end up sitting at the corner of the bar alone most of the evening, but that's a different. Yeah.
I've used such tricks too. If you know that your string literals, if you have the same string literals, you can reuse them. They're only allocated one of them. You can do them with percent. Like for printing, if you want to print different things that are the same, you don't create a bunch of different string literals. You just create one. So you will shrink your used memory.
Right.
You shrink your global.
I'll give you all another bit of, this is definitely not the same, but since we're doing parlor tricks here, let me see, let me copy this. Just in case you didn't realize you could do this.
You need the curly brace to fill in space.
So no, there's no comma or anything. That's just something that's a thing that's been around since the C language.
And they're all stored in the contiguous memory location.
Yeah, it's one string. It's just a notational convenience in case you have a large string that's more visibly appropriate to have as a set of rows displayed. All right, enough of that.
Okay. If you have multiple string literals, they're stored together also in contiguous memory locations. They're just different string literals. So you get a pointer to the character point declare multiple string levels, have a pointer, and just let it run off into the distance. Just keep incrementing in a for loop, and you will print all the strings. Like every single string will be printed one after the other because they are stored continuously.
Yep.
In the memory. Just see all bunch
Right.
of strings.
So tell me about debugging. Have your debugging skills gotten better?
That's all we're
You
sharing.
just wear everything on the insurance. You're just, yeah. No, I just wear that every Tuesday.
So what if for the students who are in this class next semester, would you have tips of how to go about debugging that were hard-earned? GDB? Would you? I'll ask this rhetorically. I don't need you to answer. Would you be able to drill down and be more specific?
Figure out how to run.
All right. So this is what I want everyone to do. I want this to be a 10-minute exercise. Everyone has to get their computer in front of them, and you can buddy up with people if you want to do this together. Is go to the course shell. And in the assignments projects, between project 3 and project 4, I've got this in-class mini assignment, debugging tips. Go ahead and you have to be logged into your Chico State with your Chico State credentials into Google. Once you've done that, you can get access to this. I'd like you to take 10 minutes and make it a little how-to tutorial on your best debugging tips.
For like this class specifically? Or just like in general?
I think in general, anything that would be useful for this class, so it doesn't have to have been learned or exclusive to this class. Anything that you think would be useful. And then I'll go through and talk about it a little bit. Let's give another 4 minutes or so. I'll be talking about introducing Project 4, and so that's other than that. All right, just another minute. You're welcome to keep adding to it, but I'll start talking again in just a minute. Monday. All right, so let's look at this. So Git, yeah, I think definitely the version control and being able to look at differences between your versions is definitely helpful because it's easy to kind of put your nose into the code and pretty soon you've changed it in 4 or 5 places and lose track of it. So I think that's definitely some good advice. Read your code. So that brings up an interesting question. Do you feel comfortable understanding at a high level the class hierarchy of expressions, constants, variables, how they're related, and the purpose each serves? What about errors? Errors as in when there's an error in writing GPL code, you report the error. Where's most of that happening? So let's grep.
Eric does. You are like in GPL.y.
Well, right. Where are most of these being reported? GPL.y. Let's see, how do we want to do for I? Let's do it this way. For I in source files, the header files, the .y, do, let's echo it. Let's grep for error, ::error, and $I. Let's pipe that into WC-L. We can do better than that. Let's go to here. I believe the option is -n. There we go. Nope, we can do better than that. Whoops. Let's change echo to printf. Let's make it a 20 wide field. And let's make it left justified. There we go. So there's a bunch in GPL.cpp. That's kind of the driver that we aren't touching directly, so we can ignore that in our counts. Error.cpp is obviously the source of all this stuff, so we can ignore that. So I've got 2 in expression.cpp, 1 in variable, and 15 in GPL.y. So yeah, definitely most of your error checking for GPL errors occurs while you're parsing. And the reason why we're able to do that is because, like C++, GPL is a strongly typed language, so the vast majority of error checking you're doing is to validate types. Then there are a couple odd exceptions, such as, I don't even know what's happening in expression.cpp. Random. So yeah, just so that's just part of having a high-level understanding of how all the code's organized. So the reading of the code. Comment. Yeah. Definitely. Come back. Let me zoom in. I can zoom in on this. Come back to your code later. I think I saw that comment somewhere else, unless I saw it in the same place. I think that's a good idea, and we talked about that a little bit. Definitely walk away and come back can often give you breakthroughs immediately. Print statements. Tell me about clog. So who's using clog? Anyone want to own up to that? You put the clog comment? Do you write to a file? Is it a fourth? Do you use it? Is it considered a fourth stream, or is it always tied to one of these other streams?
Just that's it. Or if you have multiple streams, you can redirect one of them and have
And have clog not be redirected?
Yeah.
Okay. Well, that's an interesting one. I think I knew about that at one time, but it's certainly forgotten about it. Memory diagrams. Yeah, at least having some understanding of what's in your variables or expectations of what are in your variables. That's where that assert function can be helpful. Is you're trying to debug things, you make assertions that you believe are true. I believe that this pointer is not null at this point, and things like that will definitely help you find problems when it aborts due to that. GDB stuff, how to do those things. I think this is very valuable. Don't just rely on the tests that are supplied, but we saw how you can use printf on the bash prompt to write very simple programs to test things. I think that's good. Psychology tricks. Well, that certainly helps with understanding. Start with the top compiler error. Yes, absolutely. Don't start with the one halfway down. There's the other one, walking away for a few minutes. Tell me about ltrace. Is that like strace? Is that on the Mac?
I've used ltrace once, and basically it prints out which functions are being called on the library.
All right, I'm familiar with strace. I'm not sure what. I don't have it installed on this. I imagine that's fairly similar. In my systems programming course 540, which is next semester if you're looking for an elective, we use strace quite a bit. As you said, showing function calls. It's very good at showing the system calls. Oh, there we go. So ltrace, it sounds like a nice variant of that. Okay, okay. You think this would be a good document to give to the students at the beginning of next semester? that never works. All right, good. Well, I appreciate you, and definitely stay hydrated. Don't do drugs, kids. All right. So yes, I appreciate you providing some information there. Let's talk a little bit about Project 4. I know that most of you are still trying to finish up Project 3, but in the very least, you can see what you have to look forward to. Project 4 is the addition of the game objects. That's circle, triangle, rectangle, the three shapes, PixMap, which is the object that you attach to an image, and then the fifth one is text box, right? Lets you put text up there on your graphical screen. So it's the integration of those 5 objects. And the first thing to note about them is that they have an interface. Each of them are objects of classes, or I should say they're each a class. Each of those 5 is a class, and they're all derived from a common game object class. Okay. So frequently you are working with like pointers to game objects as kind of the base class. These are basically the 3 functions you'll use primarily for interacting with objects. There are 3 functions. You can get the type of an attribute. So if you recall, these types have, where are they? Yeah, this stuff. So in this GPL manual here, right, like this, when you create this text box, all these are attributes of a text box, all these are attributes of the triangle, and they're all listed out here. So that is what this is referring to. You can say what kind of thing is X, and it'll say it's an integer. What kind of thing is red, and that's a double. So there's that function, and then you just have to, you can either write to an attribute, you give the name of the attribute, and you provide a value, or to read from an attribute, you pass in the variable that you want to be filled up. So it's passed in by reference, and whatever the named attribute is, it'll fill up your variable that way. So those are the basically the 3 functions for interacting. What you have to do to get this thing, and here's some example of how it's used, how you use them in C++. So there are, what you have to do in order to integrate the game objects then is you have to expand the constant hierarchy. We have constant strings, integers, and doubles. Now we have a constant game object. So it walks you through integrating that into the constant hierarchy. And then you also need to add support in symbol. So right now your symbols, you can have symbols to strings, integers, or doubles. Now you have the 5 different game object types that have to be supported in symbol as well. Okay, so symbol actually grows a fair amount in this project. And then finally, you have to add support in well, actually, let me not say finally. Finally, I'll say finally, we'll get to it. You have to add support in the variable class. So if you recall, if you say 3 plus a, then a is going to create a variable object. Likewise, you're going to have to do something similar for these objects. There's a new class. I guess I may as well just jump down to the bottom. There's a new, so this is how you would use variables when you're doing game objects. And there are 2 components to it. There's the name of the object, which would be your entry inside your symbol table, and then the attribute that you want to access. And so you derive a class off of a variable called member variable. And member variable will have those 2 pieces of information. If it's an indexed into an array, it'll have that index array expression, just like it basically inherits it from variable. So you have to write that variable class, and then the only other thing you have to do is you have to integrate it into the grammar. And the primary place where you're integrating it into the grammar is obviously in the variable section. If you recall, there are 4 rules that went with the variable, and you did 2 of them as for having a or a sub 5. Now you've got to do the same 2 for variables that are these game objects with and without the array index. In addition to integrating it into the grammar there, you also have to integrate it to be able to create them. So just like there's variable declaration, there is a production for object declaration. You just basically, it models very similar to how you create variables. In fact, you could almost, to a great extent, you could like copy and paste chunks of code and then use that as a starting point for editing it and getting it to work. There are definitely differences to be sure, but the general framework is the same. So that's it. The last thing that's a bit quirky is this part. So these are object declarations, and here's the tricky part right here. And what makes this tricky, let me give you an analogy to show you why that's tricky. It's because of the error reporting on GPL errors that makes it tricky. So if I say, yeah, I can do that. This is in GPL. Oops. You say int x equals 5 plus this. All right. What makes it hard, what would make this very hard would be as if your error message had to say error. That's wrong. Let me do, yeah, error. Trying to assign a string, FDSA, to variable x. Now, why is that complicated? And the thing to focus in on is this bit right here. Why is that a complicated error message to present to the user? Yeah. The variable hasn't been created yet. Think about how this thing's parsed. We get the 5 plus FDSA parsed, and then we create a plus object. And then it's only later down the road that you have the variable declaration, and it's taking that plus object as a generic expression, the optional initializer, right? So the big issue is the error has to be generated prior to ever creating x, and it has to name x. That is what makes this a pain, because when there are problems, all of these parameters get parsed prior to the creation of this object, and so any errors in these parameters, and that's the problem. The error message for these parameters say something like, W is not a valid parameter for some rect. So that's the issue. So what we have to do is we have to collect up all of these parameters, and then we don't pull them apart until we're inside the object declaration. And the way we'll do that is we'll create a simple linked list of parameters. We'll just grab the expression for each parameter and the name. So we have a name and an expression. This would be the name. This would be the expression, right? Because you could say y equals 2 plus a, something like that. You collect these up in a linked list, and then that linked list is what comes into the object declaration. You create the object, then you process the parameters by going through that linked list and inspecting the parameters. So that's a strategy we'll use for that. And that's it. That's all that there is to Project 4. I think this one has some challenges. I think definitely the the big mountain to get over is project 3. If you get over project 3, then I think you can easily handle anything else from that point on that's thrown your way. Any questions about anything? All right, so we have 15 minutes. I will go ahead and end here, and if you want me to look at your computer screen, we can do that now.